Hello, I am Spencer Mankiewicz, and my forensic failure examines the Apollo 13 incidents where an oxygen tank ruptures on board the command module. The Apollo program oxygen tanks were designed by the Beech Aircraft Company of Boulder, Colorado. They were designed to hold supercritical oxygen, which is highly pressurized oxygen that is neither a gas nor liquid. The primary parts of this oxygen tank for this analysis are the heater, fan, and temperature sensor. On April 13, 1970, at 10:08 p.m. Eastern Standard Time, oxygen tank 2 was stirred, which is a normal practice to have more accurate readings of the temperature and the pressure. However, due to improper use by the ground crew, the Teflon insulation on the fan motor was damaged, and a short caused a fire in the wire's insulation. The fire traveled up the wires until the pressure from the combustion ruptured the blowout plug over 69 seconds later. The failure tore off the side panel of the spacecraft. In the picture to the left, there is an overlay that shows how the picture on the right should be looking. You can see how oxygen tank 2 is missing on the image on the right. You can also see how the force from the rupture caused fuel cells 1 and 3 to be forced upwards. The investigation was particularly challenging since the service module burned up in the atmosphere. So how did they find this all out? Telemetry was key to how the events unfolded, along with documentation, pictures previously shown, and destructive tests to confirm their theories. The graphs on the right are the characteristics of the telemetry from the spacecraft since the fan was turned on to the rupture of the tanks. It was observed about 2.7 seconds after the fan was turned on there was a slight voltage spike, which indicated the fan was disconnected and there was an arc. The pressure then started to increase 13 seconds later, which indicates the fire was a slow burn, which matches the characteristics of a Teflon fire. The thermistor's temperature doesn't increase since it only measures the local temperature. Tank 2 had excessive documentation, and it had passed all previous tests. Unfortunately, the tank's protective thermal switches were not designed for the 65 volts used by the ground equipment, which was a design miscommunication. This, in conjunction with the draining problem it developed from being dropped, causes issues in the countdown demonstration test, a test used to determine if the rocket was safe. When the ground team decided to do was to turn on the heater to boil off the oxygen instead of letting it drain. However, the protective thermal switches could not disconnect due to the over voltage, and they fused shut. This allowed oxygen tank 2 to reach temperatures over 1000 Fahrenheit in some spots, severely damaging the insulation. Several destructive tests were also performed to confirm the failure source. The picture on the left shows an oxygen tank that ruptured due to a Teflon fire, which was used to see if the data gathered matched the telemetry. The picture in the middle shows a fused thermal switch tank after simulating the Apollo 13 detanking procedures. The picture on the right shows Teflon insulation burning in a liquid oxygen environment. The investigation team determined that Teflon was too flammable. They also found that the tank's thermostatic switches were not rated to be under the load, as well as the fans being too large of a fire risk and to be removed. The design practices that were changed was to make the designs more easily inspectable, since one of the reasons the tank wasn't inspected was because of the difficulty of doing so. The components should also be put under tests that accurately put them under load. The engineers involved in this case serve as excellent examples that we as Christians should follow. The engineers were responsible and did the right thing by putting the crew first by including multiple safety features in their design, and were able to prevent a complete tank rupture, which would have killed the crew. The engineers stayed moral, even when using Teflon, a flammable material. This is because the engineers did not know of this while designing the tanks, and as such, this failure falls under the category of inaccurate prediction of contingencies. Thank you for listening.